Okay, everybody, well, tonight we're going to take a look at solving linear inequalities. Now, basically, we're just going to take a look at how we graph them, how we can write the equation from the graph, and how we can tell whether something is a solution or is not a solution. They're really pretty straightforward, just a couple of different rules from just a regular linear equation. And so let me get started and help you figure out what those differences are. Okay, there's three basically important things that we need to remember. Number one is that an inequality is basically just like your equation, except now we're going to replace the equal sign with a inequality sign. Everything else is treated the same way. This is standard form. We know this is slope-intercept form. And so everything else will look basically the same except for a couple of nuances. Number two, whether or not I am a less than or greater than sign will determine whether or not I use a dashed line, or if I'm less than or equal to or greater than or equal to, I will use a solid line. Just when we did the regular graphs, we used an open circle when it was not equal to, and we used a closed circle when we graphed when it's equal to. We differentiate between the inequality where there's not an equal sign with a dashed line, meaning that this particular spot on the graph is not included in the solution, whereas when it's a solid line, we are including this side. And then finally, number three is because it's an inequality, we're actually going to shade, which means that whatever is on the shaded side is the solution. So no longer are we going to say only on the line is a solution. We're going to say anything in the shaded region is a solution. And obviously we're going to have to determine which way to shade depending upon which way our inequality goes, and I'll explain how that works. Okay, so those are the three big differences. It looks basically the same except we have an inequality. We're going to use either a dash or a solid depending upon whether it includes the equal or doesn't include the equal. And then after we've built our line, we're going to shade to include everything which is a solution and leave the parts that are not solutions unshaded. Okay, so let's just take a look here. It says here, is the point 0, 5 a solution? Okay, well, y is 5 greater than 0 minus 3. So is 5 greater than negative 3? Yes. Is this point a solution? Yes. Is the point 1 comma 4 a solution? Y is 4 less than 2 times 1 is 2 minus 5, 4 less than negative 3. The answer is no, 4 is not less than negative 3. So just like we solved just a regular equation to see if the ordered pair was a solution or not a solution, we're going to do the same thing here. Obviously now the inequality says it doesn't have to equal, it just has to comply with the inequality. Is 4 less than negative 3? No. Is 5 greater than negative 3? Yes. Okay. Now we're going to graph and then find all the solutions. Well, I said earlier that these are treated just like your regular linear equation. So we know that y equals x minus 2. I would go to negative 2. I know that my slope is 1, so I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, and I'm going to graph it. And that's what my graph looks like. And except I run into a problem here, is that I have to make sure that my graph, and let me undo that for me, my graph needs to be dashed. And the reason it needs to be dashed is that this inequality right here does not include this line. It just says it's greater than x minus 2. And then the last thing that we have to figure out is which way we shade. And the easiest way to do that, please do this, the easiest way to do this is to go to 0, 0 and say 0 is greater than 0 minus 2. 0 is greater than negative 2. Is 0 greater than negative 2? Yes. Is 0, 0 a solution? Absolutely. And so now we know that our graph needs to be shaded over 0, 0. And now we know that all of these places are solutions to this particular equation. So all of these areas are solutions. Okay. Now, what's the best way to solve a problem like this? Well, we use the cover-up method, right? When x is 0, y is 4. When x is 0, y is 4. When y is 0, x is 6. All right? And because this is because this is less than or equal to, I know that I'm going to use a solid line. So it's going to look something like that. Okay? And then our final process is we have to determine which way to shade. Again, I want to plug in 0, 0 and see if this is a solution. 2 times 0 is 0. 3 times 0 is 0. Is 0 less than or equal to 12? The answer is yes. And so we know that the graph must include 0, 0. Well, let's say it was the opposite way. Let's say that this was this way. Whoops. Let's say that this was indeed greater than or equal to. Then we would have 0 is greater than or equal to 12. Is that a true statement? No. So we would know that 0 is not a solution, and so we would shade in this direction. All we're trying to do is figure that out. You could pick some other points on here. In fact, if our line went through 0, 0, obviously picking 0, 0 wouldn't help us because it would be on the line. You'd have to pick another couple of points. I usually pick 1, 1, 2, 2, something very easy to plug in. Okay, and we'll talk a little bit more in class about what to do if we are right on the origin. But if it's not on the origin, picking 0, 0, if it's a true statement, then we graph over 0, 0. If it's a false statement, then we graph in the opposite direction, away from 0. All right, let's see how this works in a real-life situation. We're trying to sell croissants, and we need to raise at least $175. So we need $175. If we get $175, is that good? Yes, it's at least. And how do I make money? Well, I get money from selling croissants, 2x, and I get money from selling baguettes, 5y. And because I raise my money that way, I can now determine what my graph looks like. Well, again, we could use the cover-up method. It's a little bit more complicated here. When y is 0, x is, let's see here, divide this by 2, and it looks like I got x is 8, 87.5. And then when, let's see, we don't see that on the graph, so let's see how we're going to do this. Maybe we'll change all these to 10s. So we got right down here. Okay, just bear with me. And then when, well, that was when y is 0, sorry. And then when x is 0, y is 37. So it'll be somewhere right around here. Do our graph. It's greater than or equal to. We'll plug in 0, 0. 0 is greater than 175. That is a false statement, so we know that our graph is on the opposite side. And we could check some other numbers here. So I just took this and I multiplied everything by 10 if you wondered what I did over here, okay? So that makes it fit. All right. I think we're going to wrap it up here. I got one more example and then we'll call it an evening. Can I write the equation based upon the graph? Well, we said it's basically the same as y equals mx plus b. So we're going to take a look at this. What's my y-intercept? Positive 1. What is my slope? Well, it looks like my slope is up 1, 2, 3 over 1, 2, 3, 4. So my slope is 3/4 x. I have a dashed line. Okay, so I know that it's either going to be a less than or a greater than. And the easiest way to figure this out is if it is 0, comma, is 0 greater than 1? No. So I now know that y must be greater. So y is greater than 1. Did I do that right? I don't think so. So we know 0 is greater than 1. That is false. We know that shading is not on this side, it's on the opposite side. We do greater. The way that I like to do a quick double check, because this can get kind of confusing, is I come over to here and I say when x is 0, y is 2. When x is 0, 2 is greater than 1. This is a true statement. Is it shaded? Yes. Let's just do one more so we can make sure we've got this down, and I think we're good for the evening. My y-intercept is -3. My slope is down 1, 2, 3, 4 over 2. So my slope is -2x. And now again I have to figure out which direction. It looks like it's going up, so I'm going to do my y is greater. Looks like my shaded area is 0, 0 is a solution, so let's see if my inequality is going the right way. Is 0 greater than -3? That is a true statement. And then the last thing is this solid or is it dashed? And it's solid, so I have to go back and make that look like this. So this is my answer for graphing. All right, well, I hope this helped. Post video 24 awaits you, and we'll have more to talk about tomorrow. Good night.